Hello everyone, I'm Svetlana Levitan, and today I'm going to tell you about JVM-based libraries for machine learning pipeline deployment. Thank you for inviting me here. I came from Russia many years ago to the US for graduate study, and I studied at the University of Maryland, College Park, studied applied math and computer science. And then I worked at SPSS for many years as a software engineer implementing statistical and machine learning algorithms. And SPSS was acquired by IBM. And the last couple of years I was a senior developer advocate with the Center for Open Source Data and AI Technologies at IBM. I am a meetup co-organizer for several Chicago meetup groups. And currently I'm working as a volunteer data scientist with a small startup and looking for a permanent position. So today we are going to talk about machine learning stages and pipelines. And then I will introduce open standards for machine learning model and pipeline deployment and show some applications. And finally, we will talk about the libraries, JVM-based libraries for this pipeline deployment. First, what is machine learning? Well, most of you probably heard this term already. And according to Wikipedia, machine learning is the study of computer algorithms that improve automatically through experience. And what does it mean through experience? That means with data. So in other words, it's kind of a mathematical model, which is based on sample data. And you train the model on the data. And in the end, you can get predictions or decisions without explicitly programming the rules. And machine learning is not just a model. Machine learning usually is a process that consists of several major steps or stages. And the major stages are, well, first you need to find the data, collect, maybe merge, etc. And then you need to clean and prepare the data and apply various transformations and feature engineering. And then you build some models on the data. Usually build a few models to find a good one. But once you have a very good model, that's not the end of the story. Once you have the model and the corresponding previous transformations of the data, you need to deploy all this into your production environment so you can get predictions on the new cases, and that way you can get your return on investment. And once you deploy, again, it's not the end of the story. You have to monitor and update the model in the pipeline, and depending on the application area, this update may need to be happening very quickly or sometimes not so quickly, but often it is pretty fast. And this stage, the stage of model deployment, has been a big bottleneck for a while because it's often not easy to deploy this. And yeah, so as I mentioned, we are deploying not just a model, but the whole machine learning pipeline, which includes data sourcing, data transformations, feature preprocessing, deep learning or machine learning model, and then possibly some transformations of the predictions of the models that need also to be applied before you actually can use the results in your business. And here is how a pipeline may look like in a commercial application. This is Watson Studio, which is an IBM product, cloud-based, and you can get it. You can use it for free if you're a light user on IBM Cloud. And this was inspired by IBM SPSS modular product that came with the SPSS acquisition. In this picture, you can see those purple circles are the data sources, and then the blue hexagonals represent various transformations of the data and merging of those different data sources together. And then in the pentagons, there are models that are built. And once the models are built, you get those model nuggets, which are kind of yellowish. And then using those model nuggets, you can get predictions for new cases. So here the data flows from sources through transformations to models and decisions. And how do people create machine learning pipelines? There are many different ways to create machine learning pipelines. There are open source packages and products, and there are commercial products. So in terms of open source, here I have some of those illustrations that you probably may have heard about some of them. So Python and R are very popular open source programming languages. And in Python, there is scikit-learn library, and there are also TensorFlow and PyTorch for deep learning. And R, of course, has thousands of packages of various statistical and machine learning analysis. And if you have larger distributed data, then you would want to use Hadoop, Apache Spark, etc. And Apache Spark machine learning library has APIs in Scala, Python, Java, and R. But the core Spark is in Scala, while Hadoop is in Java. And then there are open source tools like Vika, RapidMiner, H2O, KNIME, etc. And some commercial products are IBM SPSS Statistics, which was the original SPSS product, started back in 1968. And I'm proud to say that I contributed a few models into this product. And there is Modeler and Watson Studio, and then SAS was always the main competitor of SPSS. And Salford Systems was a relatively small company that has been acquired by Minitab. And there is MATLAB, Dataiku, etc. And how do we deploy machine learning pipelines? Well, there is, of course, Docker, and with Docker, it's kind of easy to deploy various things, but then Docker is not 100%. Well, in many cases, it is very convenient, but in some platforms, you cannot just use it, or it's not appropriate. There are also several different frameworks that basically allow you to build models and then deploy in the same framework. But what if you have different frameworks in use by those people who are creating the models and those people who are deploying the models into production? Because this is often done by different teams. In that case, open standards may be a good way to deploy models. So with open standards, you get more flexibility and you can build your models in one system and deploy into a totally different system, because those open standards are kind of abstracted from those programming languages or packages that you are building your models in. And today we are going to talk about three open standards: PMML, PFA, and ONNX. And why do we want to make those machine learning pipelines portable? Because, as I mentioned, they may need to be deployed into very different environments. For example, you may want to deploy some pipeline inside a database as a user-defined function, or you may need to deploy it on a web page, or maybe in some IoT device, a smart refrigerator, or drone, or cell phone, etc. And of course, they all have different systems running inside of them. And so let's talk about some of those open standards. The first one was PMML, Predictive Model Markup Language, which was created by the Data Mining Group, the group of companies working together on those open standards. And this group was started by Professor Robert Grossman back in the 1990s. And the first standard is PMML, which was using XML as representation for the models. And currently, PMML is pretty widely used, supported by over 30 vendors and open source organizations. And here is a little example of how a regression model, logistic regression model, looks in PMML. So it is an XML document with PMML as a root element. It has a header, a data dictionary, which describes what fields we have. In this case, we just have one continuous predictor, and our target Y is categorical with values yes and no. And then regression model is the main element, is the model element in this PMML. And the function name is classification, could be also regression, clustering, etc. And here we just say the mining schema inside regression model tells us that x1 is the predictor and y is the target. And then we have the intercept and the coefficient for the x1. In open source, PMML is supported by a number of packages. The biggest one is JPMML package. It's a whole project from Estonia. It is based on Java, and it provides open source PML export for all the major open source packages. And also it has a scoring engine. But scoring engine, you have to pay them if you use it. It's not completely free. And then Nyoka exports PML from scikit-learn. And there is R package PMML created by people from Zementis, which was acquired by Software AG. And I think Nyoka also was created by Zementis. Those are packages providing PML export for R and scikit-learn, respectively. And then if you want to score PMML in open source, there is this PyPML package, which is a Python wrapper for PML4S. PML4S is a library in Scala, which does PML scoring for many of the PML models. And it is used in Project Orange, which is part of Linux Foundation AI Foundation. So PML was pretty good, except in cases where some feature or model was not yet in the standard. Then it would take a pretty long time to get it into the standard. And also in the last decade, there was this desire to use JSON rather than XML for model representation. And so Bob Grossman asked Jim Pivarsky to implement this, to design a new standard. And Jim created this portable format for analytics, or PFA, which is different from PML because instead of describing the models, it describes the scoring procedure. And it is based on JSON format, and it's a kind of mini functional math language plus schema. And you can find the information about it on the DNG website. And here is a simple example of PFA code, yes, for logistic regression also. And you can see that, yes, there is it is JSON. So you describe your inputs, your outputs, and the actions on the inputs that are necessary to get the outputs. And in terms of open source support for PFA, there are several libraries also. Hadrian was the original PFA export and scoring engine library created by Jim Pivarsky and his group. And then my colleague Nick Pentrias created this ArtFark package, which is doing PFA export for SparkML. And Woken was created by Ludovic Claude in Switzerland, and it does also some PFA export and some PFA validation. And Transmogrify is PFA scoring for SparkML using ArtFark by Salesforce. So several companies are using PFA, but I don't know exact statistics on how many companies are using it. PFA working group hasn't met for a while, although now I hear there will be next meeting soon. And talking about Ludovic Claude, he works at CHUV, which is a medical organization in Switzerland, and he works with Human Brain Project. They have this, and this is a diagram he drew for the joint poster we had at a conference in Lausanne in January of last year. So they have this network of hospitals in Europe, Each hospital has their own data, but due to privacy considerations, they cannot exchange or move the data. So they build separate models on in each hospital, and then the models, of course, don't have any private information about patients, so they could exchange the models, and they're using PFA format to exchange, validate, and deploy the models. And well, PML and PFA were pretty good, but none of them, unfortunately, supported deep learning fast enough. So Microsoft and Facebook came up with this ONNX, Open Neural Network Exchange format, and they released it in September 2017. It is based on binary protobuf format, and it covers deep learning and some traditional machine learning. And currently it is accepted to Linux Foundation AI as a graduate project. And it has become very popular very quickly because there are so many different deep learning frameworks, and it was very difficult to create converters from, if we wanted to create converters from any one to any other one, we would need n squared of them. And of course, with a single intermediate representation, it's much easier. And hardware manufacturers are also very interested in this because for them, it's much easier to support and optimize computations for just one intermediate format rather than so many different formats. And now there are so many companies and people working together on this format that it's amazing. And here you can see this slide was shown by Harry Kim at the ONNX meeting in April 2020, and it shows growth of popularity from about a year before. And you can see that there are 155 contributors as of April 2020, and more than 8,000 GitHub stars, etc. So it's a pretty popular and very active project. And how does it work internally? How does it represent models? Well, there is the ONNX graph, which is a directed acyclic graph, which has information about operations. And if we express it in JSON, it looks like that. And then there are tensors with all the weights, and all this is packaged into a single file. And there is a whole ONNX ecosystem, which includes converters from various frameworks, and the ONNX spec. There is also ONNX Model Zoo, which has many libraries. Many pre-trained models that you can just take and use. And to deploy ONNX, you can either convert it into one of those frameworks for which a converter is available, or you can use ONNX Runtime, which is a separate open source project created by Microsoft. And there are also several tools, open source tools for visualizing the models represented in ONNX. So now let's finally get into the libraries for the pipeline deployment, as I promised you. So today we will talk about several of them as listed here. And as I mentioned, JPML is probably the biggest one for PMML. It was created and maintained by Villu Rusman, who is in Tartu, Estonia. And that project includes 38 repositories in GitHub, and most of them are in Java. Well, there are a few in Python and R to help export PML from those languages, but most of the repos are in Java. And here is a list of various packages for which PML is supported, and you can see it's a pretty big list, and it includes SPSS too. So At SPSS, we export PMML in many for many models, and JPML scoring is supporting them. That. And then the PML4S library is an open source library for scoring PML. It is in Scala. It can work with Spark. And to use it, you just load a model using method from file, and then you can get your predictions using the method predict. Hadrian, as I mentioned, was a project for PFA, version 1 for PFA, reference representation. And here is a part of description. So basically, you can use Hadrian both as a command line utility, or you can integrate it into an application, or into a website, or in a Java servlet, or in Hadoop, etc. So it's pretty flexible. I believe my colleague Nick did some performance testing, and he found that the scoring by Hadrian was not was kind of a little slower than scoring for PML models. So maybe there are ways to improve it. Unfortunately, this project was not updated for the last 4 or 5 years. So yeah. And then ArtFark, as I mentioned, created by Nick Pentres, who lives in South Africa, actually. And that library makes it very easy to export a PFA from Spark ML models. And here we have a piece of code that just shows you how to export PFA. So basically, yeah, this piece of code actually builds a pipeline. And then you call this function to PFA, give it the model, the information about metadata, and then you get your PFA out of it. And talking about ONNX, of course, ONNX main library is the ONNX runtime, where you can actually run the scoring for ONNX models, or inference it's called. And the ONNX runtime is implemented, I believe, in C++ mostly, but it does have Java API, so you can use those Java API to pretty easily score the models in ONNX as well. Now, Spark ML is probably the biggest JVM-based system for machine learning, and pretty widely used. As you know, Spark works with distributed data and can handle very large amounts of data. And Spark has API in Scala, Python, Java, and R, but the core is in Scala. And then pipeline that you can produce with Scala, Python, or Java could be saved, and then you can later restore it with any of the other languages. With R, it's slightly different. And then there is mleak, which is a separate format that they use to serialize models, and then you can deserialize and score those pipelines with mleak. And you can also deploy the models using the open standards that I mentioned before. Okay, so conclusions are that open standards enable easy machine learning model and pipeline exchange and deployment. And there are several open source JVM-based libraries that work with those standards. And if you want to contribute to open source, there are many opportunities, many great projects that could use your help. And I will finish with showing you some of the links about the libraries that I was talking, the standards and the libraries that I was talking about. You can see those links here on this slide. And thank you so much. You can follow me on Twitter. And thank you for your attention. I will take some questions now. Thank you. Bye.